Hello, PreCalc. How you doing? It is the 10th of February, 2017. The reason I said 19 is because 39 years ago today, I was in labor with my first baby, and she was a girl, and it's her birthday, obviously. So you'll be watching this on this joyous day, and either that, it is the weekend edition, so you'll either watch it on Friday the 10th or the 11th or the 12th, the weekend edition. So here we go. An old friend of ours, partial fractions. The reason I'm going over that is I'm preparing you for a test that we will ended up having on Thursday. Monday was a review, you're out of town, and on Tuesday, Wednesday's review, and so we'll conclude our studies on this section on Thursday. Write down this problem, negative 5x plus 4 over x squared minus x. I want you to write it in partial fractions. We're decomposing it so that we can use it much easier and an easier way when we have a calculus lesson in the future. So preparing for that day, let's go ahead and take the denominator always and factor it. When you have two terms, you can only factor it if it's a difference of two squares, which this is not, or remove the common factor. I see there's an x in both, so I will remove it. Factors like this. The top I'm going to leave unfactored. Now, I recall that I can write that as a over one factor plus b over the other factor. All right. So if you remember, the next step causes us to multiply through by the least common denominator in order to clear all the fractions from the denominator. So I'm going to use an x minus 1, and that's all. So multiplying through, here's what we get. This denominator will cancel this whole multiplier, this whole thing we're multiplying by, and just leave the numerator. The x and the x will cancel, but it will leave the x minus 1. And when they come to the b term, the x minus 1's cancel, leaving the x. All right, so now I would like to play the let x equal game. Let x equal, I scan my problem here and I see, well, if I let x equal 1, that will simplify some things. So I'm going to get 5 times 1 plus 4 equals a times 0, so this term is gone, plus b times 1. All right, I don't need that plus. All right. 5 plus 4 is 9, and I got it wrong. What did I do here? I said let x equal 1. Oh, sorry, this is a negative 5. Negative 5 plus 4 gives me a negative 1. All right. All right, put your two hands down. I see it. So b equals 1. So I go up here and I replace b with a minus 1. I'll go ahead and just do that with my magic eraser here. The old paper towel works every time. All right, so the b becomes minus 1. Now I got to find a, so I'll play the let x game again. Let x equal, scanning here, let's get rid of that term, so we'll let x equal 0. Putting a 0 in as I go across, I get 0 plus 4 equals a times 0 minus 1 plus b times 0, which is 0. Move the negative 1 to the other side, and I get a equals minus 4. Going back to the original. All right. This fraction and this fraction are equal. But one day in calculus land, you will be asked to take the integral of this. And this is very difficult. And in a few days, the calculus class this year will be able to do this. If they've forgotten how to do partial fractions, they will come to you. All right, that's the first problem. Let me set up the second one. All right. All right, the next one is negative 7x minus 15 over x squared plus 6x plus 9. All right, this is going to take on a complication that we didn't see in the first example. So let it begin. Let's factor that. All right, did you notice that the bottom factored like that? That's called a repeated factor, and these are set up differently. So I'll go ahead and set it up over here. I'll write it as I often do, a repeated factor. I write it as that factor squared. All right, coming back over here, writing it again. I'm going to show you how to set it up. This time, we put a over just the factor before it's repeated, x plus 3, and the second factor is over the factor repeated. So do you recall how we did that? It just works this way, so you just recall and remember that when you have a repeated factor, one that's squared or cubed or any factor here, then you put the first term, the a will be over the factor that is non-repeated, and then the second will be over the repeated part. So it's a little different than you might suspect. You might suspect it would be a over x plus 3 and b over x plus 3, but it won't work. So this is how we set it up with repeated factors. Now, if this was to the third, you would have x plus 3, b over x plus 3 squared, plus c over x plus 3 cubed, and so on. All right, let's multiply through. We'll multiply through by the x plus 3 squared, and as we are wont to do, we get 7x minus 15. Here, this cancels one of those factors, but the other is still there, and this cancels entirely. And it's time to play. Let x equal. Let x equal is going to be minus 3, and so I get minus 7 times minus 3 minus 15. This will zero out, and it equals b. Positive 21 minus 15 equals b, so I get b equals 6. And go back up here and rewrite it, 6. All right, to get a, I will say, it really doesn't matter. Usually, if there's no obvious choice, I pick x, let x equal 0. So 0 minus 15 equals a times minus 3, plus 3, 0 plus 3. Plus b is already known. We know what b is because we just calculated it to be 6. So instead of putting a b here, I put a plus 6. Let's move the 6 over. Minus 21 equals 3a. Divide by a, and we get a equals minus 7. All right, these two expressions are equal to one another. This one is difficult to work with in calculus. This one is easy peasy. All right. One more, the third complication that we learned. And we only did 2 of these, I believe. You saw me do a couple. All right, we have one more to look at. One more complication, and here is the problem. 3x squared minus 3x plus 10 over x minus 2 times x squared plus 4. Sorry. All right. the complication that this one presents is one of our terms is quadratic. That means that the degree of the variable is 2. And if you look back, our factors on the first two examples were linear, degree 1. So even though we had repeated factors, each factor was linear. So we're going to set that one up a little differently. Do you remember what we did? It starts out the same. We're going to use this factor, a over x minus 2. But when we get to the x squared plus 4 term, I'm going to put the x squared plus 4, as you might suspect, on the bottom, but on the top is where the difference comes in. I'm going to put a bx plus c. And the reason being is that when this is quadratic, the numerator has to be 1 degree less, which is linear, degree 1. Here, our degree was 1, so in the denominator, the degree in the numerator is 0. So there's always a difference of 1 degree when you hop from the denominator to the numerator. So we had to put that x in there for this to work out. All right, so we're going to continue like we used to, multiply through by the common denominator. Made a mess. All right, x minus 2 times x squared plus 4. We're going to multiply that through. And when we do, this whole denominator is canceled by that. So it leaves 3x squared minus 3x plus 10. This term, these denominators, this denominator and this factor cancel, but it leaves the x squared plus 4 factor. This one, x squared plus 4, cancels, but it leaves the x minus 2. All right, keep the bx plus c in parentheses. It works together as a unit. If you leave it off, it means the c will distribute to the x minus 2, but the bx does not. And I want them both to distribute. These are connected to these by distribution. This will go multiply through, and so will this. So you have to indicate that by putting that whole factor in parentheses. All right, let x equal. All right, the game is sweeping the nation. Let x equal game. We're going to look down and see what will simplify our work. Bing, bing, let x equal 2. So 3 times 2 squared minus 3 times 2 plus 10. All right, putting in 2 for x. A is 2 squared plus 4. B, x plus c, in parentheses, b times 2 plus c times 0, 2 minus 2. So that's going to go away, and that's why we chose 2. All right, 2 times 2, 4. We get a 12 minus 6 plus 10 equals 8a. And over here, 12 minus 6 is 6, plus 10 is 16, equals 8a. Divide by 8, we get a equals 2. All right, so that came out nice and sweet. As you remember, some of them don't, but these do anyway. So I'm going to go up here where I had my a and replace it now with 2. All right, we have to find b and c now, so let me go back. Oops, I didn't have to erase that part. Let me put that part back. 3x squared minus 3x plus 10 equals. All right, this part. All right, now we'll play let x again. Let x equal. So what should we use this time? All right, can you tell me? Let x equal. Say it a little louder. All right, Maggie, I'll take yours. Let x equal 0. There isn't a real obvious one here that will zero out any other terms, so we'll just take 0. So we have let x equal 0. So I'm putting in a 0 here. I get 0 minus 0 plus 10 equals a, I already know, is 2. 0 squared plus 4 plus b times 0 plus c times 0 minus 2. All right, simplifying, I get a 10 here on the left. 2 times 4 is an 8. 0 plus c is a c times minus 2. Pull the 8 over, and it becomes a 2, subtracting, and minus 2c. Divide by minus 2, and I have c equals minus 1. All right, I'm going to go up here and put in a minus 1 for c. And we still have to find b, so we have one more let x equal game. We've already used, what did we use? 2 and 0. All right, shout it out. What do we want to play this time? Let x equal. All right. I hear Haley. All right, let x equal. Haley, thank you for your help here. We're going to do what you suggested. Let x equal 1. All right, so when we started, we saw 2 would be helpful. We just picked 0 and 1 because at least they're low numbers to work with and don't cause us too much trouble. So 3 times 1 squared minus 3 times 1 plus 10 equals a, oops, we already know a is 2 times 1 squared plus 4. B is what we're looking for, times 1. Now we know c is minus 1. And let x equal 1 minus 2. All right, 3 minus 3 is gone, so we have a 10 on the left. 2 times 5 is 10. Here we have a b minus 1 times a minus 1. So 10 equals 10. Distributing the minus 1, we get a minus b and a plus 1. All right, we move 10 plus 1 is 11. All right, now we move the 11 over, we get minus 1 equals minus b, or b equals 1. So I go up here and I would rewrite in a 1. I could do that, but 1x reduces to x, so we don't really have to write it in. So we have decomposed this fraction, this rational expression, to this one. In calculus class, this would be difficult to work with. This would be nice to work with. All right. So that will end our review on partial fractions. When you come in on Monday, I'll give you some to practice. And you'll be all ready, ripe and ready. See you then. Bye.